Start. Right. Welcome back, everybody. We're just waiting for people to file in and we'll slowly start. Thanks for being with us till 2:30 on an afternoon. There's been some great talks today, back to back. I really appreciate your attention and time for the second and last day of the conference. Oh, bless. Thank you, Chloe. Right, so let's get going. We have the next talk from Pooria Sohi. And Pooria, unfortunately, can't join us today, but he has recorded his session and he's done a fantastic intro with a good mug of him. So you can see that. So without further ado, I'll request Amy to play Pooria's presentation to us. We're going to be talking about how to reduce manufacturing waste at the design stage with Pooria Sohi, who's actually representing Autodesk. Thank you.
Hello, everyone. My name is Pooria Sohi. I'm a product marketing manager and industrial designer at Autodesk, and I'm very pleased today to be speaking to you about how to reduce manufacturing waste at the design stage. First of all, my apologies that I can't be there in person and that my talk is pre-recorded, but I will let you know how you can reach out to me if you have any questions or comments at the end. Just a little bit about me. I am formally trained as an architect. I practiced architecture for a few years. I finished my master's with a specialization in sustainable master planning before finally switching to a career in industrial design where I focused on additive manufacturing technologies. At Autodesk, I have been a general consultant for sustainable practices, working with a number of startups and various industries and businesses to imbibe sustainable practice into what they do. As a result, I am unfortunately burdened with a little bit more knowledge on what it really takes to make a sustainable product. So that's what I'm going to be going through with you today. So I wanted to start with the core points. Probably been a long day. You've absorbed a lot of information. And so if there's anything you take away, it would really be this. Efficient and sustainable design is really, really difficult to achieve. Primarily because sustainability as a whole is largely misunderstood. The general rhetoric that we have around the subject is an oversimplification of what it takes to really reduce waste and be sustainable. The most control that you have as a designer are the decision-making factors, whether that's the choices that you make in the design itself, the specifications, the manufacturing and the suppliers. This is really where you can have the most influence. And lastly, if there's just one point that you take away from this today, it's that you have the choice to educate yourself on the matter. And if it's something that you really wish to start to participate in, the first step is learning more. I do also at this point wish to let you know that on my own journey in this subject, I would say I know enough to know that I know next to nothing about the matter. So I want to level set a bit. Saying that we largely misunderstand sustainability can be a bit of a nebulous statement. The way that I tend to think of it is that the existence of recycling bins is a symptom of design and manufacturing failure. What does that mean? Well, if you look into the history of recycling, most of the impetus to create recycling as we know it today came from corporations offsetting their responsibility to the consumer. That then created a chain reaction that have led us to where we are now, where most of the conversation around sustainability is at the consumer side of things. Doesn't really make sense to do that because most of the energy and the waste and the consumption in general happens in the process of making something. For example, every single one of you presumably has a smartphone in your pocket. Well over 95% of the environmental impact that that product has had happened before you even purchased it. And that last 5% is assuming that you change your phone every few years. So why is it so complicated? Well, the simple fact of the matter is you have to consider literally everything. And when I say literally everything, I really do mean literally everything to be a truly sustainable product. Here is just a simple list of some of the things. This is not even comprehensive, but starting with the decisions that you make as a designer all the way through to the diet of the people who work in the factories making your product, all impact the environmental impact of the thing that you're making. You know, if you think about where the material is coming from, how it got to the factory, how people commute to and from where they're working, how you as a designer are working on the product, how long it took you, how much energy you're consuming, the way that you get your energy. These are all just some of the things that one needs to consider. But that can be incredibly exhaustive and kind of make you fall down a rabbit hole. So what can you control? Well, I tend to think of it in these three buckets. There's complexity, so complexity of the product and processes and manufacturing itself, the decision-making around where you get the thing made, how you get the thing made, what processes you're using to make that thing, as well as the design decisions that you make around the reliability and or the durability of your product. So let's start with complexity. Well, you've probably heard before that more complexity equals more cost. But there's more to it than that, right? I like to think of this simple equation, like more complexity equates to more time, which equates to more energy, which equates to more consumption, and a byproduct of every single one of those steps is waste. But let's define this a little bit more. So you have invariable complexity when designing a product, and you have variable complexity when designing a product. The invariable complexities are the things that happen at the definition stage. So the product specifications, the product features, and the product capabilities. If you as the designer are part of those conversations, you're able to influence how complex things are going to be. Specifications, of course, are going to be the definitions. So what is the thing that you're making? You know, how big or small is it? How much is it going to cost? Where is it going to get made? And what does it do? And then features and capabilities sometimes get muddled. Features to me are the sort of delighters, the bonus aspects, or the way that you as the designer make the product sticky, right? Like a well-designed product is sticky. It's something that people keep using. And you have the ability to define what those are before pen hits paper. Capabilities are the functionalities of the thing. Now, we live in a day and age where you can get really, really complex products because they're so filled with capabilities and features. Doesn't have to be, though, to still be effective. And then there's variable complexity. So this is where you have a lot of very direct influence on the product. So geometric complexities, you know, like how many compound curves are you using? Is it more organic or is it more orthogonal? What materials are you using when defining what your product is going to look like? And then how is your product actually assembled? Like not just how the parts are made in the factory, but how is the thing then put together before being completed? So let's drill down into those a little bit more. When it comes to invariable complexity, there are certain things that we have to accept as realities of the 21st century. You know, modern problems require modern solutions. We can't return to a pre-silicon age. Eliminating aspects of a product is great when you can do it, but there are also expectations, right? Like no one is going to buy a car from the 1930s and drive it around today as a daily driver. It just doesn't make any sense. Using a horse and cart, for example, might be fun, but probably not the most practical thing. So looking at product specifications, having the influence to adjust the definitions, the needs, and most importantly, the longevity of the product, these are things that you as the designer are an authority on. You have the experience, you know what works and what doesn't work, what delights and what doesn't delight, and you're able to influence what that looks like. And just to touch on longevity for a moment, longevity does not equate to a single release. Like building a product that lasts, building a product that stays with a person does not preclude that you only make one version of that thing and call it a day, right? You can make things that last forever and stay with a certain audience, but that doesn't preclude that there won't be more consumers, right? We're an ever-growing population. You constantly have more people coming into the specific demographic brackets of what you might be making. So building something that someone buys once and lasts forever does not preclude that you don't have to, that you simply have to stop there. You can make new versions of things, right? Product features, again, there are certain realities like, what do you need to be competitive? Being sustainable sometimes gets muddled with making something that meets a very specific set of requirements at the behest of its success. These things are not mutually exclusive. And then there are the things that you can cut out from features. Like, what is there just because it's nice? Like, there are so many products out there that will have a laundry list of features, but in reality, when it comes down to the end user, how much of that stuff are they actually using? How much research are you doing as a designer into past products to see the efficacy of the various things that were in there? How much of it was there because it sounded really good but didn't actually get used, and what is actually being used? Which leads to the next point of what can you solve with marketing that doesn't need to be solved with design? The more holistic that you're able to be when thinking about your product, the better you can be at making these kinds of decisions. An iPhone is a perfect example of this. If you look at an iPhone and iOS platform versus the Android platform, well, the Android platform is so much more feature rich and capable of doing a lot more because it's not the walled garden that Apple has made around iOS. But when you look at sales, the iPhone grossly outperforms its competitors in the Android side of things. And there is a compelling argument to be made that a lot of that has to do with marketing and branding and not the actual product itself. And then product capabilities, right? So less is more. Not everything needs to be smart or feature packed or behave like a Swiss Army knife. And that's kind of what I was touching on earlier on. Focused products tend to solve problems better. And when you look again at the longevity, people hold on to focused products for far longer than the ones that take a kitchen sink approach, unless that kitchen sink approach is done really, really effectively. We also have a tendency to focus creep. So what is the problem that you're trying to solve? And what do you need to do to stay laser focused on that? What are the arguments you need to make to the broader team to not just throw things in there because someone believes it's going to help the product be successful? So your greatest asset as a designer, beyond the ability to design delightful products by working on them and ideating and concepting, is the ability to communicate needs against wants, not just with the customers, but with the stakeholders that help make the product. Then there's variable complexity, and this is a little bit more direct. This is more in the kind of traditional vein of what people think of when we say the word design, right? There's the geometries, the final form that the object takes. Complex shapes equate to greater complexity in manufacturing. The more complex you are with manufacturing, the more waste you're going to produce, whether that's through the byproducts of manufacturing or just the energy required to produce the thing that you're working on. Now, it's not a universal rule. In fact, nothing that we're going to discuss today is going to be a black and white series of statements. They all are context sensitive. It's going to be context sensitive to the product. It's going to be context sensitive to the market. It's going to be context sensitive to the availability of materials and the manufacturing processes. But the more that you're conscious of that, the more intelligently you can make decisions around what you are producing. And then there's the material. Again, this is a perfect example of where that nuance comes in. You know, it's very easy to say, okay, well, we just won't use plastics. And that's great. And I'm not saying that you shouldn't do that. But there are certainly contexts in which the plastic part will actually have a smaller environmental impact and less waste produced than alternatives. It really just depends on what you're making. The other question to ask yourself is, how difficult is it to work with the material specified? Okay, injection molding stuff is great and working with plastic is great, but if you've ever seen what goes into an injection molding machine, it is crazy complex. It's very, very refined, but it's really, really complex. And then if you look at CNC machining, if you're milling out metal parts, there's tons of chips produced because that's a subtractive process. You have to start with a block that you carve the object out of. And that has its own benefits and drawbacks, but you can recycle and reuse a lot of that material. And then lastly, there's assembly. So the decisions you make about your product create complexity. It's an unavoidable reality. You as the designer are really supposed to find that balance, right, between meeting the need while not overdoing it or underdoing it. It's a tightrope walk. A great way of exemplifying this is glue versus fasteners. Now, glues in general are really handy in a fabrication environment, but they impact repairability. If you've ever damaged, for example, an iPad, trying to repair it yourself is a very difficult thing to do. You need to heat gun it to soften the glue up, peel it away, make the repairs, strip and clean all the glue that was there off, and then reapply it. That's not even touching on just how awful in general glues are for the environment. So fasteners might make more sense, but maybe you're working on a product that needs to be waterproofed. In that case, glues might be better than fasteners because you have to add a lot more stuff into that product to make it happen. So really, really want to drive home the point that your context is going to be really, really, really the deciding factor in what definitively makes the most sense for you. Next, let's dive into manufacturing specifications. So we've touched on materials a little bit, and I want to drill down into that a bit more. So let's just define a few of the things that are worth considering. There's invariable waste and there's variable waste. The invariable waste is the byproducts of production. Every process that you use to make something generates some kind of waste in that process. Injection molding has waste plastics. It requires a lot of energy to heat the plastics up into a liquid state and then more energy to cool it down into a solid state. Casting requires tons of heat, and warming anything up is one of the kind of most energy exhaustive exercises that we take part in. And then there's material burn. And material burn in this context is really referring to the nature of that material and like what it passively does in an environment. You may not be aware of this, but for a great example of material burn is vinyl records. So vinyl records off gas the second you take them out of their sleeves. As soon as they make contact with air, they start releasing gases out of that plastic. And those gases are really, really bad for you at home. If you're breathing them in, it's carcinogenic. It's something that the material naturally does. There's other forms of material burn as well, like how the material behaves when under load or duress and how it's going to respond to how it's pressed and forced against. Now, I'm not saying you need to be an engineer or an expert, but the more that you know about these things, the more informed the decisions you can make, which leads us into variable waste. So the material choices that you're making are going to impact waste. You might be weighing up whether you manufacture something in a certain way and the materials that you're using, and the considerations that you need to make are, where is that material coming from? How available is it? How easy is it to recycle it? How easy is it to work with it? And then the process by which I'm manufacturing with that material, how much energy does that actually take? So the processes of production are something that you have influence over, and you can influence those in the designs that you're making. The simpler and more orthogonal an object is, the more that our established manufacturing supply chains are set up to produce that part. So let's drill down again. Invariable waste. Now, we've touched on a few of these things already, but I really want to drive this home that every manufacturing method creates byproducts, and no single system is definitively better than another. The things that you want to consider when weighing up the various production options available to you are material waste, the fumes that might come off of that, how much carbon dioxide and carbon monoxide are you going to be spewing out into the atmosphere as a byproduct of the manufacturing process. What kind of chemical wastes are being produced when you do something? If you've ever 3D printed with photosensitive polymers, those resins are just awful for the environment. They produce wonderful prototypes, but once that prototype is made and you have that solid state, what do you do with that? How do you get rid of it when you're done with it? And it's just one tiny example of what you're doing in that design ideation stage that impacts the totality of waste produced by your product. And how extreme is the energy consumption? You know, if you're casting something out of metals, it takes a heck of a lot of energy to get metals to a liquid state. But that doesn't preclude that you shouldn't use them. Again, a lot of this is going to be about weighing up the options against one another and making informed decisions on what makes the most sense in the context of what you're producing. And not to forget about material burn, right? Every manufacturing method produces material burn. The waste or the slag produced through making, right? We've talked about injection molding, and we've talked about CNC chips. There's waste and slag from casting and injection molding. Every single one of these processes creates a form of waste or has greater or lesser energy consumption to achieve the desired result. thinking about how your decisions in the design stages cascade down to manufacturing is one of the most important things that you can do. So variable waste is really going to be about the design decision processes. While material waste in manufacturing is unavoidable, it can be minimized. Picking the material and picking how the thing is made is really going to impact the environmental impact and the waste. So it's really up to you to learn more about how much energy goes into making a certain thing a certain way and comparing those. Again, you really don't need to be an expert in these matters, but knowing enough will help you make those decisions when you're designing the product. Then there's repairability and durability. Now, these are two of the biggest concepts that are discussed in designing sustainably. If you make something repairable, it can last a really, really long time. It can be disassembled, it can be worked on. And if you make it durable, well, that object is super, super tough, meaning it's going to withstand a lot of bashing and dropping and pretty much anything else that might get thrown at it and survive.
Yeah, I just thought it would be useful because we have this video from Pooria that will go on for a while. And we also have Ugo starting, and he's going to exactly cover this topic of repairability. But there's some great conversations happening online. And I thought I could give the floor to some of the people here who have had experiences designing the space. So maybe I'll take this one from Marieka, who's working in brand marketing. American, I'll try and put you over here on call. I hope that's okay for you. Do you want to share your experiences of what it is like working in this space? Let me see if I can just promote you. Just 1 minute. Yes, you can speak now. Can you hear us? Narika? I think you're on mute.
Am I unmuted
Yes.
now?
Perfect.
Yeah, I was just writing in the chat in terms of sort of marketing choice and material choices. There's definitely some changes that we're looking into internally within the company that I work for. And a lot of it comes around to, in particular, when you think about print materials, you know, it's not just about recyclable paper. You also have to think about ink, for instance. So one of the things that we're looking into is using vegan ink, which can be a great way to become more sustainable as well. And there's other things to think around, which is, again, the usability of what you're creating. So for instance, event season, using certain banners for multiple events can be really, really valuable as well.
Brilliant. Thank you. Moving on from that, we also have Greg from Oz here, and I'd love to ask Greg to share his perspective because he's mentioning how much should we make and market that which is wasteful, energy intensive, and the like, perhaps encouraging the shift to a genuinely responsible living economy that prioritizes best ecological practice and prevention over cure. So he's also shared with us a link to a paper, and maybe Greg, you just want to talk through what your thoughts are? You can speak. I think you're available to have a chat.
Yeah, a fascinating discussion, and the paper is actually about responsible design, but it certainly does cover all of the things that we've been talking about, and it's very easy to get focused into silo thinking, which focuses very much on one particular area, but there's a whole lot of shared issues and shared problems, and the paper and the idea of a responsible living economy really addresses all of those. So yeah, there's a lot of good stuff just covered. And it certainly does beg the question, how much should we be encouraging the manufacture of things that are incredibly energy and resource wasteful, and moving more towards alternatives, or looking at how we can at least develop and share best practice on a larger scale, rather than this is fantastic tonight, but it's still a small effort in comparison to what's needed.
Absolutely. Do you have any case studies or examples, Greg, from Oz or Australia that's doing or addressing this issue locally?
Yeah, the paper actually has a few good examples. Just to come up with some appropriate ones now.
No worries, yeah, understand.
It's a little challenging, but...
No worries, I was just wondering if it had something, but we've also run out of time. I just wanted to make sure that because we don't have Pooria on the call, and there were some great topics that the audience has covered here, people have asked for where this presentation is. Amy will be sharing a link. You can see the whole talk and film online from Pooria, so we didn't mean to cut it off. I just didn't want to lose this opportunity to have this chat with you all. But we will be moving on to Ugo. Ugo's talk now, which covers repairability. And there'll be many more issues that we can take up with Ugo as well. So thank you so much. Amy, can you share the link to the video, or do you have a link to Pooria's presentation?
It will be put online on the platform where all the other recordings have been placed. So if you just give us a couple of minutes, it'll be up there.
Brilliant. All right then. So thank you, everybody, and catch you in the next chat. See you online.
Thanks for the opportunity. Cheers.